Hello. Today we're going to be talking about direct, joint, and inverse variation. These are different types of relationships that relate values to each other. The big thing you need to know is that in all of three of these relationships, there is some value k that is called the constant of variation. K is the constant of variation, which means that number's not going to change. If x and y change, the k will not. So the x and y will be your variables, and if you have a z, that will also be a variable. Let's start with the most common. That's direct variation, also known as y equals kx. So this is made so that y will go up as x goes up. So I picked an example here. If y equals 250x, the k is going to be 250. Now, if this is the cost I'm going to have to pay after how many gallons of gas I purchase, if gas is $2.50 a gallon, then I'm going to take the number of gallons of gas I have, multiply it times 250, and that's going to be how much I pay. Now, if I have more gallons, I purchase more gallons, then I have to pay more dollars. So if I pick 10 gallons, I have to multiply that times 250, and that'll equal the cost, which would be $25. So the more gas you put in your tank, the higher the price you have to pay for it. Depending on how much you put in your tank, the price per gallon is not going to change. That's your K, but the cost will. So as X goes up, so does Y. Inverse variation, it's the opposite. As Y goes down, as X goes up. So if X goes up, then the Y has to go down. So this is written two ways. Either X times Y will equal K, or the Y will equal K divided by X. Most commonly, I think of rate times time equals distance equation. So if I have X times Y equals 120, maybe I have to travel 120 miles, then the rate, or how fast I'm going, miles per hour, times how many hours am I driving, will take to travel 120 miles. Well, if I'm traveling at 60 miles per hour, then I can find how many hours it's going to take to go 120 miles. So looking at this, I can solve. My k is the distance because that's not changing, but 60, I can divide both sides by 60, and that leaves me how many hours would equal 2 hours. Okay. But if I wanted to change this and I needed to get down there in a hurry, I could change my speed. And so if I travel, let's go crazy. Let's go 90 miles an hour times how many hours. I can still solve, divide by 90, divide by 90. And how many hours will it take? It'll take about 1.5 hours. So just another way to think about this. You're only saving a half hour if you excessively speed. Kind of interesting. The third type is called joint variation, and joint variation combines both direct variation and inverse variation. So there's three variables, and an example of this would be the volume of a cone. The volume of a cone is 1/3 the area of the base times the height. So if the base gets bigger, then the volume is going to go up. Or if the height gets bigger, the volume goes up. But if the volume needs to stay the same and the base gets bigger, then the height would have to get smaller. So you have both relationships. As one goes up, so does the other. And as one goes up, the other might have to go smaller. So we can solve for any of these three variables if we have two of them. So joint variation looks like y equals kxz. In this case, the 1/3 is our k, is our constant. Most commonly, what you're going to have to solve is you're going to have to solve situations where you're either finding k or you're going to have to find an x or a y, but they may not give you k. So the first thing you're going to look at is which of these three is it. If they say varies directly, that's a direct variation. So I know I'm working with the formula y equals kx. Next, I need to find out where I have both x and y, when I have two of the three variables. Now, they didn't give me the k, but I know that 18 is a y when x is 15. So 18 equals k times 15. Now, you can solve this with a proportion, but with different varies directly, varies inversely, varies jointly. It's just easier to solve for k first. So as I look at this and go to solve for k, I know I can divide by 15 on both sides, and that leaves my k all by itself. That leaves me an 18/15. So I'm going to reduce this to a 6/5 is my k. Now that I know that k is a 6/5, I can go back to this exact same equation, and I know it's going to look like a y equals 6/5 x. I can come and solve for y if I know that x is 20. So if I know that x is 20, I can take 20 and times it by 6/5, and that will equal the y that I'm looking for. So 6/5 is a fraction, or it's a divide by 5 if you want to think of it like that. I want to start with 20, divide by 5 is a 4. 6 times 4 is a 24. That is what y would have to equal. So I can solve for x's, I can solve for y's, I can solve for k's. The easiest way I know how is just to solve for k first and then plug it back into that formula. And you don't have to worry about which kind of proportion you need to make. So solve for k and plug it into either the direct variation equation, the inverse variation, or the joint variation. Let's do one more. Suppose y varies jointly. Okay, if they're saying jointly, I know I'm working with y equals kxz, three variables this time. Find y when x is 9 and z is -5. Now, in this first situation here, I only have two of the three values. So to start out, I need to start with all three. So they're saying the word if y equals -90, z is 15, and x is -6. Now I have a complete set, so I can solve for the k with that. So -90 in the y equals k, I'm not sure yet, but x is -6, and z is 15. Now, to make it easier, I can multiply these together. I know that -6 times 15 makes -90. So -90 times k will equal this -90 here. Divide by -90 to get k by itself. Divide by -90 to get k by itself there. And k has to equal 1. Well, now that I know that k equals 1, I can go back to my joint variation equation, y equals 1 x times z. And now I can find y when x is 9 and z is -5. So I'm going to plug in a 9 for x, a -5 for z, and now I can solve for y. So 1 times 9 is 9. 9 times -5 is a -45. And now I found my y. So it'll probably be helpful for you to write these equations down. Remember that the formula for direct variation is y equals kx, k times x. Inverse variation, is either x times y equals k or y equals k over x. And joint variation is y equals kx z. Y equals k times x times z. Remember, k is your constant of variation. So x and y's are your variables. K is that constant. And if you wanted to graph these things, direct variation is linear. And because there's no add or subtract in it, your linear line always goes through the origin. Likewise, inverse variation, the graph of that is going to be irrational because you have an x on the bottom, and so there's going to be some asymptotes, and those asymptotes will always be your axes. And joint variation has 3 variables, so you would need a 3-axis grid to graph those, so you won't usually be graphing those unless you're working on some isometric paper. But hope this helps. Have a great day.